Welcome to the tutorial on how to use a DE10-Lite. The DE10-Lite will come in a box like this, and it'll come with basically a USB cord from which it'll be powered, as well as a program, and it'll come in this bag right here. It's a black bag, an anti-static bag. Some of these bags will also be silver, might be silver metallic in color. Some of them might look like this material here, the pinkish color. They're all anti-static bags in which the board is shipped because a board could be damaged by basically electrostatic discharge. You might not notice that the board will be damaged, but over time, over a period of time, it does damage the board. So this is the board itself. Open this package only in basically a static-free work environment. Preferably you'll work on top of the anti-static mat that will be provided in lab. And this is basically the board that we'll be using throughout CST-162 and CST-133. So let's go over some features of this board. So here we'll have the Altera Max 10 FPGA. Note the part number, which you might need to use later on. You'll have an accelerometer, which we won't use much in this class. It'll have 10 switches as well as 10 LEDs. We have 6 7-segment displays over here. We have 64 megabytes of SD RAM, which we won't be using. On this board in particular, which is pretty cool, we'll have an Arduino connector right here, so we can plug in Arduino Uno compatible boards such as this one. What else do we have? We have 2 buttons over here, as well as a VGA, and we have a 40-pin header over here for other input and output. Over here we have the USB connector for which this will power the board or will program the FPGA on the board. So here's a block diagram of the board. So let's see, what else do we have here? Here in the user's manual, which will be posted on the course website, we have basically a guide on how to program the FPGA. So if you forget how to program it, you can reference this guide. Okay, so here we have basically tables and a diagram that shows how the clock signal is connected to the FPGA. This is the FPGA pin, and this is basically coming from some sort of clock generator device. And it provides a 50 megahertz clock to the Max 10 device through pin N. Let's see, ADC clock comes into pin N5. We have a clock 1 and a clock 2 at 50 megahertz coming in to pin P11, as well as N14. We have basically 2 user-defined push buttons called key 0 and key 1. Coming into pin B8 and A7. And we have the user-defined slide switches. Okay, so the signal name in your software will be SW0, and SW0 on the board is this switch. This switch is in turn connected to C10 on the FPGA itself. We also have user-defined LEDs over here where, let's see, A8 is connected to a resistor through LED, and it's called what? LED R0. So LED R0 is connected to pin A8. And from this diagram I can tell you that if you send a 1 to LED R0, you'll get the LED to turn on. If you send a 0, it'll turn off. So we also have 6 7-segment displays connected directly to the Max 10 device. This one shows hex 0. So basically, if we want to display the number 1, we'd light up the number 1 here and segment 1 and segment 2 here. So we have 7 segments in total, plus the dot pixel. So technically, we have 8 signals. So this one hex 0 display, which is this guy right here, the rightmost 7 segment, So it goes hex 0, hex 1, hex 2, hex 3, hex 4, hex 5. So hex 0, if we want to light the number 1 on this display, we would illuminate 1 as well as 2 while not illuminating the rest of them. So hex 0 at 0, this one right here, is connected to pin C14 on the FPGA. And it gives the rest of the 7 segments as well in this table. Here we have the general purpose I/O connectors. Let's see here. Some of these, pin 11 and pin 12 are 5 volts and ground. Pin 29 and pin 30 are 3.3 volts and ground. The rest of them are GPIO, available for your use. And here's a table describing that. And this is actually pretty important because this is your Arduino expansion header. This is how we're going to plug in some of the expansion boards we'll be using throughout CST133 and CST162. So remember, if you're going to plug in something, turn the board off and then plug it in. Let's see, how does this go? Okay, so it plugs in like this. But we actually won't use the LCD shield today, so I'm going to take it back off. Remember, remove power before plugging in anything to the board. Now the expansion header I/O pins are labeled this way in this diagram right here, figure 319. And here is a table describing that. And here is also the VGA port. You actually don't really need to know much about the VGA port because we're going to give you some code that displays stuff through the VGA port, but for the most part we're going to kind of black box it so you don't have to really deal with that for now anyway. And there's SD-RAM, but we won't be using that. And I don't think we're going to use accelerometer sensor either. And I think that concludes basically the manual. So how do we program this board? Well, we program it using something called Quartus Prime. So let's go ahead and look at how we're going to do that. And let me see if I can minimize this window here. Okay, so I'm going to launch Quartus Prime. Sometimes when you type in Quartus into Windows 10, it sometimes pulls up Quartus Prime 16 or some of these other things about Quartus Prime. You need just Quartus Prime 16, this one right here. So we'll click on here and we'll launch the software. One more thing, I did tell you that the user's manual is going to be located on your instructor's website. Now, what we're also, license file not specified. Okay, so I got my licensing server issue fixed. If you do run into issues with the license server, contact the lab manager. So I did forget to tell you that this board is available for purchase from Terasic. So you can actually go to their website and buy the DE10-Lite. Let's see, max 10. This is a DE10-Lite and the academic price is $55. It's a pretty good deal. The other thing is, to program this board you'll need the Quartus Prime software. So we can go ahead and basically, if you're in the lab, it'll be installed for you. You'll just use it. If you do want to work on this at home, which you can, because you can buy your own board as well as get the software, you can use the Lite edition of the Quartus Prime software. You'll notice things like Quartus Prime versus Quartus 2. Basically, it's more of a rebrand, so sometimes you'll see Quartus 2. Your instructor probably means Quartus Prime. Also notice that the Intel baud Altera, so a lot of things will be labeled Intel FPGA instead of Altera now. You'll see a mix of those things. So you can go ahead and download the Lite edition for your home use. And let's see, the latest one is 17. When you download it, we will not need area. We won't need any of this except the Max 5 device support. Oh, sorry, we don't. Not Max 5. We're on Max 10 now. So Max 10 device support plus the Quartus Prime as well as ModelSim Intel FPGA edition. That'll allow you to simulate stuff. So that's what you would download, okay, if you were to set this up on your own computer. So your instructor will most likely give you a template file. Two things will be on your instructor's website: the DE10-Lite user manual as well as a template. The template file will basically what we'll be using throughout CST 162 and 133. So unless otherwise specified, what we'll do is we'll just extract the contents of your template folder, and I'm going to relabel it. Let's say we're working on Lab 1. Alright, so we got Lab 1 here, and I'm going to open it up in Quartus. But when you open up Quartus, you might not get the correct one. You don't want the programmer, you don't want the Design Space Explorer, any of this stuff. You just want Quartus Prime version 16. You can also open it up from just double-clicking the QPF file. In this case, it's called template.qpf. Double-click on that and see whether it launches. Great. It launched. Wow, this is pretty slow. Okay, there we go. So we look at the project navigator. We have a tasks menu here. We want to go to the project navigator. Make sure it's on hierarchy view. If you want to view your files, go to the file view. Double click on template here, and this basically what I talked about earlier. We have the SD-RAM, the clock signals, the 7-segment displays, the keys, the LEDs, switches, VGAs. All this input and output can be driven through this template file. And one thing I want to check out is whether the switches on the board and the LEDs work, as well as how to configure these 7-segment displays. So the first step in doing that is, what are our switches and LEDs called? Switches are just called switches, LEDs are just called LEDR. So basically what I can do, since this is the same size, is do an assign statement. Assign LEDR is equal to, what was it? Switch. Right. We could also assign them individually. If we're doing this individually, we would do LEDR at, let's say, 0 equals LED or switch at 0, or switch at 1 or something, whatever switch you want to assign to LEDR 0 at 0 or LEDR at 0. Okay, so I've assigned the switches. The other thing I want to figure out with this board is, do I send a 1 to turn on these LEDs or a 0 to turn on the LEDs, these 7-segment displays? So what I'm going to do, like we mentioned earlier, there's like 8 pins. So I'm going to do assign, and I remember 7 segments are hex 0 and hex 1. So for one of them, since I don't know right now, I'm going to do assign hex 0 equals 8 apostrophe B, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to do an assign statement, hex 1 equals 8B, 1, 2, 3, 4, 1, 2, 3, 4. I'm basically going to try to figure out whether these are active high or active low. So after we've coded everything, let's go ahead and compile. Right? We're going to go over here and compile. Double click on compile design. Okay, so it looks here like we have an error. When you see an error, just go for the first error. So here we say line 73 near assign, expecting semicolon. So we look before and after, and we see that I forgot to put a semicolon over here. So I'll put a semicolon over there. save it, and I'll try to compile the design again. While that's working, let's talk about how you plug in your board to the computer. A lot of times you'll have an extension in the lab. Let me see if I have one here. You'll have this extension here. Try not to use these. They're a little bit, when you get it too long, sometimes it stops working. So plug this end directly into a USB port on your computer, and we'll plug the other end into the board. And this board particularly here has a default program loaded, so it's going to go through the default program. Your board may not do that. So let's see here. What we also want to do, our compilation has finished, all green marks, so we're good. But I do also want to check something, because this sometimes happens in labs. So I'm going to check the device manager, and I'm going to make sure that this board is installed. Oh. Okay, so I'm going to go here, and it says Altera USB Blaster. Altera USB Blaster is installed properly. If it's not and it pops up as a exclamation mark, what you could do is, well, you can't do it here, but basically you'll tell it the location of the driver, and the location of the driver is basically C Altera or C Intel FPGA, depending on the version of your software, 16 or 17. Then we're going to go into Quartus. Then we're going to go into drivers, and then USB Blaster. And depending on whether you're on 32 or 64-bit, you'll tell it where to pick up the driver from. Sometimes you'll run into this issue on your own computer or the lab computer. Just go to the device manager and make sure that the Altera USB Blaster is installed properly. In this case, it is. So let's get back to what we were doing. We're going to program the device. Double click here, right? Program device. Okay. So here it detects it. Well, let's say it doesn't detect it. Let's say it comes up this way. No hardware, right? We'll plug it in. We'll do hardware setup. Double click on USB Blaster and click close. Make sure that your device is the correct device, as well as the program configure is checked, and it's JTAG mode here. Make sure it's the 10M50DAF8484 device, right? So F484. And all we have to do is click start. And hopefully it will successfully program. Okay, great. It's programmed. So, according to the code, let's go here. Oops. Let's see. Let's go to the template file. I assign the LEDs to the switches, so let's see. As soon as I flip the switches, the LEDs turned on, so that seems to be working. And let's look at this. This is hex 0 and this is hex 1. Hex 0, in code I assign hex 0 to all zeros. It seems to turn it on. And a hex 1 I assign to all ones. It seems to turn it off. So this is an example of active low. So if we send a 1 to a particular bit in the 7-segment display, it actually turns it off. And if we send a 0 to the 7-segment display, it turns on. Okay, so let's go ahead and X out of Quartus. Remember to save your files to a safe location. Make backup copies as you're working. Let's review the precautions about this board. First of all, you can purchase your board for $55 directly from Terasic if you'd like one. We'll use Quartus Prime software, version 16 or 17 from basically Altera or Intel FPGA to program this device. Right? Remember that when you're plugging it into a computer, plug this board directly into a computer. Don't use extension cords because sometimes those don't work quite right. When you're done with the board, unplug it and put it into the ESD bag which came with it. Also remember that when you're plugging in accessory boards to basically unplug this board from power before plugging these guys in. Okay.